Hello, ladies and gentlemen. Welcome back after your break. And we are going to start Chapter 6 today. It is our last chapter before your Christmas final. We're going to do nth, roots, and rational exponents today. I am really hoarse, so hopefully it won't get too bad while we're recording. The objectives are that we're going to evaluate many different roots, not just a square root, and then we're going to study the rational exponents, which basically means a fractional exponent. All right, if I have the nth root of a, okay, I'm going to write that as the nth root of a. That means the same thing as a raised to the 1 over n power. The denominator is always telling you what number of root you are taking. So n is called the index, and a is called the radicand, which means basically the number underneath the house. Okay, so I can make it a little bit clearer. Alrighty. And then, for example, if I took the square root of x, I could write that as x raised to the 1/2 power. So those two things mean the same thing. Alrighty, and let me get a calculator so I can illustrate some things. If I have the square root of 25, you know that that's 5, okay? So I'm going to show you that if I do 25 and I raise it to the 1/2 power, a couple of things about doing this in your calculator. The fractional exponent always has to be in parentheses. So as I bring in my calculator, I'm going to do this math right here. So I'm going to do 25 raised, parentheses, 1 divided by 2, close, go, and I get 5. So the 1/2 is the same thing as doing the square root of 25, and I get 5 both ways. So it's just different ways to write the same math. Alrighty, so now I need to give you some rules. So I'm going to write if, okay? And then I'm going to say if n is an even integer, and a is less than 0, which means a is negative. Okay, it's just another way of writing that a is going to be negative. That means that there are no real roots. There would be imaginary roots. It just means that there's no real roots. But we know how to take the root and get an imaginary root, so that's okay. Okay, alrighty. Where'd it go? Ah, poop! Well, maybe it's still going. Huh, that's nice. Well, there you go. All right. If a is equal to 0, that means that there is one root. And if I wrote it as the nth root of 0, I would just get 0 because the square root of 0 is 0. It's kind of boring. And then if I have a is greater than 0, which is another way of writing that a is positive, that means that I'm going to get 2 real roots, okay? All right, and remember that means if I'm taking the square root of n, or an even root of n, it's going to give me 2 answers, plus or minus. So for example, n could be 2, n could be 4, 6, 8, etc. Those would all be even roots. Anytime there is an even root, I get 2 potential solutions, plus or minus. I could rewrite this as plus or minus a to the 1 over n. Alrighty, and now I'm going to continue. I'll underline this. And now I'm going to do what happens if n is an odd integer. Okay. If n is an odd integer and negative. Okay, so remember that a is less than 0 means that it's going to be negative. Okay. So if I have the nth root of a, that's going to be the same thing as a to the 1n. Okay, a little bit of scribbling. Alrighty. So that would be if n is an odd integer, for example, it could be a 3, a 5, a 7, something like that. Those would be our odd integers, okay? If a is equal to 0, again, it's pretty boring. That means I'm going to take the nth root of 0, and I'm going to get 0, okay? If my a is greater than 0, which means that it is positive, then I'm going to get one real root, because the signs become more important when I'm talking about odd integers, okay? And so that would mean if I took the nth root of a, then it would be a to the 1 over n, and it would have one solution. All right, let's start doing a couple of examples, okay? So our directions are going to say, find the indicated root. All right, we're going to do this one in our calculator. So I'm going to tell you that n is equal to 3 and a is a negative 216. So the n tells you which root they want you to find. So I'm going to rewrite it as the third root of a negative 216. And I don't have that memorized, so I'm going to bring in my handy dandy calculator, see if I can get it all on there, okay? And I know you can't see it, I'm sorry, but we'll go from here. So I'm going to do, in parentheses, my negative 216. Notice I used the negative that's at the bottom of your calculator, not the subtract sign. And I'm going to raise that to the 1/3. Noticing again that I'm putting my third in parentheses. If you have one of the graphers where when you do the caret and everything stays at the top, then you have to be less careful. But for these older calculators, we have to be really careful with our rational exponents. And then I'm going to hit enter, and I got a negative 6. So my solution to this one is a negative 6. And what that means is if I multiplied a negative 6, a negative 6, and a negative 6, 2 negatives is positive times 1 more negative is negative, and that would give me the negative 216. So my answer is a negative 6. All right, let me turn the page, and we'll do another example. Okay. All right, this time it's the same directions, find the indicated root, and a is equal to 81. All right, so now I want to find the fourth root of 81, okay? So I'm going to rewrite this just so you can see it in different forms. I want the fourth root of 81, and in my handy dandy grapher, I'm going to do 81 caret 1 divided by 4. I would recommend that you not enter decimals like 0.25, because if it's a number like a third and you round it to 0.33, you can get the wrong answer. So I would recommend that you always do it in fractional form. So I'm going to do 81, and I'm going to raise it to the 1 divided by 4, and I get 3. So my solution on this one would be 3. All right, oops, incorrect. I have a plus or minus because it is a fourth root, and 4 is even. Therefore, I have 2 solutions. So I must be careful with that. All right, so now let's go back and, or sorry, I guess we're not going back. Let's get some rules for our rational exponents. All right, and remember, a rational exponent is a fractional exponent. Okay. All right, so if I have a to the m divided by n, okay, a couple of things to remember. M is the power, and n is the root. So the denominator is always going to be the root. Okay, I could rewrite this as a to the 1 over n raised to the m. Remember, this says take the root, this says raise it to a power, and a power to a power is multiply, so it turns out to be actually the same thing. I could also rewrite this as the nth root of a to the m. So all three of those things say the same thing. Now if I raise it to a negative m over n, remember that a negative exponent changes the location of a value. So this is going to be 1 over a to the m divided by n. So this is going to be 1 over, and I'll write it both ways, 1 over a to the 1 over n raised to the m, or I could write it as 1 over the nth root of a to the m. All of those things would be okay, and they would all say the same thing. All right, so now we're going to do some examples, and we're going to evaluate by hand. Sometimes we'll have to use our calculator to help us with the math, but I want you to do as much of it without the calculator as possible. So our first example is going to be 16 to the 3/2. I'm going to start by rewriting it, and I'm going to write this as 16 to the 1/2 raised to the 3rd. And just to make sure that you understand, I'm going to write this as the square root of 16 raised to the 3rd. Well, the square root of 16 is going to be 4, and I'm going to raise that to the 3rd power, so that I'm going to get 64. And 64 is going to be my answer. Notice that I didn't include the plus or minus, okay, because when we're doing a problem like this, we're going to consider the principal root. All right, I'm going to do another one to evaluate by hand. Alrighty, and I'm going to do 32 to the negative 3/5. So the first thing I'm going to do is I'm going to manage the negative exponents. So I'm going to do 1 over 32 to the 3/5. Notice that it's now positive. Now what I'm going to do is I'm going to rewrite it with the 5th root. So it's 32 to the 1/5, and then I'm going to raise that to the 3rd. Okay. Well, the 5th root of 32 is 2. And if you didn't know that, you could do that in your calculator. I just happen to know that. So the 5th root of 32 is 2, and then I'm going to raise that to the 3rd power, so this is 1 over 8. And 1 over 8 is going to be my final answer. Okay? Alrighty, so let's do another example, and it will be worded a little bit differently. This one's going to say to approximate. We like the word approximate because it means that we get to use your calculator. If it says evaluate by hand, you have to do most of the math by hand. On this last problem, if you didn't know that the 5th root of 32 was 2, you could have done that in your grapher, but then you would have had to show the rest of your work like this. When it says approximate, that means you get to use your grapher. Okay, so if I'm going to approximate 9 to the 1/5, I'm just going to do that on my calculator. See if I can get it in where you can see it. I'm going to do 9, and I'm going to raise it to the 1 divided by 5. We always round to 3 decimal places, and that's going to be my answer. Super simple when I get to do it on my calculator. If you forget to put the fractional exponent in parentheses, what your calculator does is it raises 9 to the 1st power, which would be 9, and then it would divide 9 by 5. Okay, not the same thing as finding the 5th root of 9. All right, let's do one more example. Let's do 12 to the 3/8, which means I'm going to find the 8th root of 12, and then I'm going to cube it. So again, I'm going to use my handy dandy grapher, and I'm going to do 12 raised to the 3 divided by 8, and I get 2.539, always rounding to the 3rd decimal place. So nice. All right, so the next step in this process is to solve some equations. Okay, so our next example is going to have us solve an equation. And our equation is going to be 4x to the 5th is equal to 128. Whoa, that's really blurry. Okay, a couple of things to remember about solving an equation. Number one, you want to isolate the variable. Okay, by subtracting or adding or multiplying or dividing. And then what I want to do, usually my next step is to undo math done to the variable. So for example, if I have x squared equals something, and I want to solve for x, my first task would be to do the opposite of squared. Well, the opposite of squared is raising it to the 1/2 power, which is the same thing as taking the square root of both sides. But as you can see in the equation that we have here, I'm going to raise it to the 1/5 power eventually, so that's why I wanted to show you this way. A power to a power is multiplied, so I get x to the 1 is equal to whatever that number was raised to the 1/2 power. Okay? And then, depending on the directions, then you could get a decimal. Or you could leave it as the square root of a number and the square root is reduced. So let's start solving this problem. The first thing that I want to do is divide both sides by 4. So then I'm going to get x to the 5th is equal to 32. Now I need to undo x to the 5th, so I'm going to raise this to the 1/5 power, and I'm going to raise this to the 1/5 power. 5 times 1 over 5, I get x is equal to the 5th root of 32, and that happens to be 2. So in this particular equation, our answer is 2. Alright, so let's do another example with an equation. Again, it's just going to say to solve, and I'm going to have x minus 3 raised to the 4th is equal to 21. I can't manage the 3 until I get rid of the 4. So the way that I'm going to manage the 4 is I'm going to raise both sides of the equation to the 1/4 power, because a 1/4 is the opposite or the reciprocal of 4. On the left-hand side, I get x minus 3, and on the right-hand side, I'm going to get the 4th root of 21. Now I'm going to add 3 to both sides, and I'm going to get x is equal to 3 plus 21. I'm going to write it this way because that's the way I'm going to do it on my calculator. Okay. This is an even root, so when I take an even root, I have to have a plus or a minus. So I could leave my answer as 3 plus or minus, and then there's my 4th root of 21. Or I could do the decimals. So I'm going to do the decimals next. I'm going to have 3 plus, and then in parentheses, 21 raised to the 1 divided by 4, and I get 5.141 as my first answer, sorry. I'm going to do second enter, brings that last operation right back up. I'm going to change that to a negative and hit enter. Sorry, the glare is kind of bad. And my second is 0.859. And those would be my two solutions. So depending on how the problem asks you to leave the solutions, I could leave it like that, or I could leave it in the second format. Alright, I have one more example for you, and then we'll get to your problems. So that's kind of nice. Fairly short video to start after our break. So this also says to solve, and my equation's going to be 1 over 4 x cubed is equal to 2. Now to start solving this one, to isolate my variable, I need to get rid of the 4. So I'm going to multiply both sides of the equation by 4. Remember, I can do anything I want to an equation if I do it to both sides of the equation. 4 times a 4th is 1, so on the left-hand side I get x cubed. 4 times 2 is 8. Now I need to manage the exponent of 3. The opposite of 3, or the reciprocal of 3, is a third. So now I'm going to have x on the left-hand side and the third root of 8, which happens to be 2. Okay, and again, if you didn't know what the third root of 8 was, you could do this in your calculator. I just happen to know a few of my roots, and so I knew that the answer was 2. Alright, so now for your problems. Really nice and short video to get us started again. The first set of directions says find the indicated root. Okay, and of course they're going to be real. Eventually we would find imaginary roots. So number 1, I want the 4th root, and the number that I'm finding that of is 625. Remember, this is an even root, so you need to be careful with your signs. Number 2, I want the fifth root of A is equal to 243. All right, let me turn the page to get the rest of your problems. Okay, so the first two were fairly straightforward. Okay, all right, the next set say to evaluate without a calculator. Okay, at some point you may have to use it, but I want you to show all steps because that will be my expectation on your homework and on a quiz or test. Number 3, I want you to evaluate 4 to the 5 hats. The next problem, I want you to evaluate 81 to the 3/4. Okay? Your last two problems, I want you to approximate. Remember, this is a great word because it means you get to use your grapher. Okay? Number 5 is going to be 4 to the 2/5. Yes, it is exactly opposite of the number 3. And then number 6, you're going to do 64 to the -2/3. So when you're done, both of these should have decimal answers. Alrighty, nice and sweet. I hope you do well on these problems, and I'll see you tomorrow in class.